All right, this is section 2.4, complex numbers. So we're going to start off with what is the imaginary number I? I is equal to the square root of -1, which means that I squared is just -1. So if b is a positive real number, then the square root of -b is I times the square root of b. We just can pull that -1 out front. A complex number is a number in the form a plus b times I, where a and b are both real numbers. Real numbers are a subset of the complex numbers. So basically that means that any real number can be written in this form, except that b would just be 0. So then it just becomes that first number. And then this important piece called a complex conjugate. If the complex number is a plus bi, the complex conjugate is a minus bi. So we're going to write each of these in terms of I and simplify, and then write the answer in our complex number form. For the square root of -50, we're going to start by breaking this down. Well, I'm going to take out that -1 because that's tricky. Then 50. Well, I know that a perfect square that goes into 50 is 25 and times 2. And then remember, with our square roots, we can break it into separate square roots. Because I know the square root of -1 is I. I know the square root of 25 is 5. And the square root of 2 is stuck. Now, the technically accepted way to write these is to put the 5 first, and then the I, and then the square root portion last. So 5i square root 2. Our second problem. I know it's tempting to say, oh, okay, well, if I could separate these, I can mash them back together and call it the square root of 90. Don't do that. We have to deal with these negatives first. Remember that this is -1 times 6, and this is -1 times 15, which makes it I times the square root of 6 times I times the square root of 15. Take those i's out front together, then I can mash my two square roots together, making it I squared times the square root of 90. Well, I squared is -1. The square root of 90 can be made into 9 times 10, which means I have -1 times the square root of 9 times the square root of 10, which is -1 times 3 times the square root of 10, or -3 square root of 10. Please be careful with that, because if you had tried to mash it together at first, you lose that negative. Let's put a box around this just for consistency. All right, same thing on these. Deal with the negatives first. The square root of -63 could be simplified into -1 times 9 times 7, all over the square root of 7, which makes it the square root of -1 times the square root of 9 times the square root of 7, all over the square root of 7. Now those square roots of 7, they can cancel, leaving me I times square root of 9 is 3, which we usually write as 3i. All right, for the next one, this looks like something we could have gotten when we did quadratic formula. Let's simplify the square root of -125 first. So I'm just going to write that part, and we're going to plop it back in a moment. Well, I could make this -1 times 25 times 5, which is the square root of -1 times the square root of 25 times the square root of 5, which is I times 5 times the square root of 5, better known as 5i square root 5. So back to our original, we call it -10 plus 5i square root 5 all over -5. Just like when we simplified before in the quadratic formula, we just kind of ignore the I and the square root of 5 part now. These can all be divided by 5. Well, actually -5. So that makes it +2 minus 1i square root 5 all over 1. So we get 2 minus I square root 5. All right, some practice problems for us now. The square root of -16. Well, the square root of -1 times 16 Square root of negative 1 is I. The square root of 16 is 4. So we get 4I. For the square root of negative 56, I'm going to make it negative 1 times. Well, 56 could be 4 times 14. The square root of negative 1 gives me an I. The square root of 4 gives me a 2. And the square root of 14 is stuck. There's our answer, 2I squared 14. For the square root of 7 times the square root of negative 21, we want to make that I square root 21 right away. Pull that negative out front in the form of an I. Now the I can hang out. Multiply my 7 and my 21, I get 147. And I happen to notice that 49 can go into that 3 times. So I get the square root of 49 is 7, and then my I, and then my 3 that's still stuck in the square root. For 8 minus the square root of negative 12 over negative 2. Well, the square root of negative 12, let's just do that off to the side here, can make it negative 1 times 4 times 3. So that is 2I square root 3 all over negative 2. Divide everything by negative 2, I get negative 4 plus 1I square root 3. Now let's talk about other powers of I, because in your answer it is not acceptable to leave I to a higher power. Anytime I have I, it's just an I. If I have I squared, we already said that's negative 1. Well, I cubed could be broken down into I squared times I, which is negative 1 times I, or just negative I to the 4th power could be I squared times I squared, which is negative 1 times negative 1, which is positive 1. I to the 5th power is I to the 4th power times I, which is 1 times I, or just I. I to the 6th power is I to the 4th times I to the 2nd, which is negative 1. I to the 7th power, 8th power, it's just going to keep going on a rotating basis. I can count out what power I'm going to be at. So 1, 2, 3, 4, then it repeats 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, on and on forever. So I to the 13th power, I can take that little table that I just made and say, okay, first power, second, third, fourth, 5, 6, 7, 8, 9, 10, 11, 12, 13th power. It's going to be the same as regular, just I. For a negative 19th power, I have to get a little creative. So when I go backwards, this is I to the 1st power, which means this is I to the 0 power, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, 9, 10, 11, negative 12, 13, 14, 15, negative 16, 17, 18, negative 19th power is the same as just I. I can always just count that out. So let's try I to the 64th power. Well, I noticed that 64 is a nice multiple of 4, which means it's going to be the same as I to the 4th power, which is just 1. For I to the negative 30th power, I'm going to count backwards. Every negative 4th power is the same as this, as I to the 4th power. So that says I to the negative 28th, 29th, 30th. I get negative 1. I to any power can be rewritten as either I, negative 1, negative I, or positive 1. Now, let's play with some more imaginary numbers. We're going to perform some operations. We're going to start with adding and subtracting, and then we'll get into multiplying and dividing. So to add and subtract, it's really just the same as with polynomials. We combine our like terms. So since I have a minus here, I actually want to distribute that minus and make it minus 2 minus 4i. And then my plus 5 plus 7i is fine. So combine the numbers that don't have i's on them, the real numbers. 8 minus 2 plus 5 is 11. Then combine my i's. Minus 3i minus 4i plus 7i is 0i. My final answer is 11. This one, we just have to FOIL, just like we would have with polynomials. Negative 5 times 3 is negative 15. Negative 5 times negative I is positive 5i. 4i times 3 makes positive 12i. And 4i times negative I makes negative 4i squared. Combine my like terms, I get negative 15 plus 17i. Now here's the trick. I squared is negative 1. So negative 4 times negative 1 makes positive 4. You can never leave an I to a higher power. So really we have another set of common like terms. I get negative 11 plus 17i. And it is the acceptable way to put your I at the end. For 4 minus 7i, no, I cannot just say 4 squared minus 7i squared. I have to do 4 minus 7i times 4 minus 7i and FOIL that out. 4 times 4 is 16 minus 28i minus 28i plus 49i squared. That gives me 16 minus 56i. But please remember, I squared is negative 1, so that turns my plus 49 into a minus 49. And when I combine 16 minus 49, I get negative 33 minus 56i. Let's multiply these two. These are what are called complex conjugates. They have the same real part, the same imaginary part. One's a plus, one's a minus. 10 times 10 is 100, plus 30i, minus 30i, minus 9i squared. Notice here, my plus 30i and my minus 30i cancel. My minus 9i squared becomes a plus 9, and I just get 109. Now the fact that a complex conjugate, well, a complex number times its complex conjugate makes a real number is what we're going to use here. Because remember, you are not allowed to leave square roots in the denominator of a fraction. Somebody said that's not okay, which means we can't leave an I in the denominator of a fraction because it's technically a square root. So to get the square root out of the denominator, we are going to take both the numerator and denominator and multiply by the complex conjugate of the denominator. So I'm going to multiply by 1 plus 5i, and what I do to the bottom, I have to do to the top. So on the top, I FOIL. I get 2 plus 10i plus 3i plus 15i squared. On the bottom, I FOIL. I get 1 plus 5i minus 5i minus 25i squared. So the top becomes 2 plus 13i minus 15. The bottom becomes 1, my i's cancel, plus 25. So I get negative 13 plus 13i over 26. And this one actually, I can divide everything by 13. So I get negative 1 plus 1i over 2. Let's try the second one. I have an imaginary number in the denominator, which means there's a square root, which means I have to fix it. I multiply the numerator and denominator by the complex conjugate of the denominator, 2 minus 7i. FOIL out the top, I'm going to get 10 minus 35i plus 12i minus 42i squared. FOIL out the bottom, I'm going to get 4 minus 14i plus 14i minus 49i squared. Simplify my numerator, I get 10 minus 23i plus 42. Simplify my denominator, I get 4 plus 49. Combine like terms again, I get 52 minus 23i over 53. All right, now a couple more to try. And I apologize, my original problems were wrong, so I just rewrote them. All right, for this first one, we are adding and subtracting, so we want to distribute that subtraction. So it becomes 6 plus 7i plus 3 plus 2i plus 4 plus I. And we're just combining like terms. 6 plus 3 plus 4 makes 13. 7i plus 2i plus I makes plus 10i, and there we have it. Second one, we just want to multiply. 3 times 2 is 6. 3 times 8i is plus 24i. Negative 5i times 2 is minus 10i. And negative 5i times 8i is minus 40i squared. Combine my 24 and my 10i. That makes 16 plus 14i. Remember, minus 40i squared makes plus 40. So really we have 46 plus 14i. And for my last one, we have to multiply the numerator and denominator by the conjugate of the denominator, which is 1 minus 2i. FOIL out the numerator, I get 3 minus 6i minus 7i plus 14i squared. FOIL out the denominator, I get 1 minus 2i plus 2i minus 4i squared. My numerator becomes 3 minus 13i minus 14. My denominator becomes 1 plus 4, which makes my final answer negative 11 minus 13i over just 5. And now, the really fun part, solving these problems using the quadratic formula. Now we can no longer say no real solution. We're going to actually figure out our imaginary solutions. So just like before with quadratic formula, we have to get it equal to 0. So I'm going to add that 13 over first. Gives me x squared minus 6x plus 13 is equal to 0. Now, I'm telling you, these are quadratic formula problems, so we're going to dive straight in. X is equal to negative b, which is negative 6, plus or minus the square root of b squared, which is negative 6 squared, minus 4 times a, which is 1, times c, which is 13, all over 2 times a, which is 1. This simplifies to 6 plus or minus the square root of 36 minus 52, all over 2. And 36 minus 52 I apologize, this doesn't match your notes either. This should be a 12. We're going to change those all to 12s, which makes this 36 minus 48, which makes it a square root of negative 12 over 2. Now we have already simplified the square root of negative 12, but just to remind you, it's negative 1 times 4 times 3, which makes it 2i square root 3. So I get 6 plus or minus 2i square root 3 all over 2. And I can divide the 6, the 2, and the 2 to get x equals 3 plus or minus I square root 3 as my 2 answers. Let's try the next one. We got to get it equal to 0 first. So I subtract the 12x. I get 8x squared minus 12x plus 5 equals 0. Dive into quadratic formula because I've already told you that's what you got to use. Negative b, which is negative 12, plus or minus the square root of b squared, it's negative 12 squared, minus 4 times a, which is 8, times c, which is 5, all over 2 times a, which is 8. To simplify, I get positive 12 plus or minus the square root of 144 minus 160 all over 16, which is 12 plus or minus the square root of negative 16 all over 16. The square root of negative 16 is 4i. Now I can divide everything by 4, which gives me x equals 3 plus or minus I over 4 as my 2 solutions. Now this says completing the square and using the square root property. You can ignore that direction because that's not what we're going to do. We're just going to use quadratic formula again. We're going to subtract the 5 over. I get 4x squared plus 8x plus 92 equals 0. I can tell you this doesn't factor. We're going to dive in. Negative b plus or minus the square root b squared minus 4 times a, which is 4, times c, which is 92, all over 2 times a, which is 4. Simplify a little, I get negative 8 plus or minus the square root of, let's just see, 8 squared minus 4 times 92, negative 1,408. All over 8. Now, one thing that I would probably recommend, I actually factored a 4 out originally when I did this before, and then I have smaller numbers to work with in here. But we're going to make this work. All right, let's simplify the square root of negative 1,408. Well, I know I'm going to take an I out for that negative. So now I just have to simplify the square root of 1,408. And I'm just going to guess and check until I find a perfect square that goes into it. And I noticed that I could divide it by 4 3 times, which is 64. There we go. I simplified it into 64 times 22, which is 8i square root 22. The square root of 22 can't be simplified any further. So I have negative 8 plus or minus 8i square root 22 over 8. Divide everything by 8, so I get negative 1 plus or minus I square root 22 as my answer. And one last problem for us. We're going to get it equal to 0. We're going to add 8 first. This time the 8 can combine with that 31, so I get x squared minus 4x plus 39 equals 0. Again, it does not factor. Quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Clean that up a little. I get 4 plus or minus the square root of, let's figure out what that is, 16 minus whatever 4 times 39 is. My calculator tells me that's 140, but negative. Let's simplify the square root of negative 140. Well, let's see. I know I got to take an I out. I know 4 will go into it. 4 times 35. So it doesn't get great, but I can make it 4 times 35, which is 2i square root 35. I guess that'll be my simplified version. 4 plus or minus 2i square root 35 all over 2. Divide everything by 2, I get 2 plus or minus I square root 35 as my solutions.